So we have conics. So when we talk about intro to conics, we first always talk about conic sections. And so what are conic sections? Well, conic sections are basically just sections of a cone. So we're going to draw a cone real quick. We're going to draw just a little ellipse real quick. This is kind of hard to do with one hand, but it'll be fine. There are easier ways to do this, but this is just how I'm doing it. So we have a cone. Now remember, when we're visualizing this cone, we always remember that this goes on infinitely, but for the sake of, well, I guess page space, we can only do a little bit. And this will be enough for what I'm going to show you. And so conic sections are basically just shapes that you can get off of a cone using a two-dimensional plane. So the first conic section that we're talking about, there's four, is the circle. And so we're going to visualize this cone again, but in a much simpler fashion. So basically, in order to get a circle from this section, we're going to take a two-dimensional plane and we're going to go straight down the middle. This is completely straight and parallel to this plane. It is a 180-degree plane, so to speak. And so if you were to look from the top of this cone, you would get, first of all, we'll draw the plane. You would get a circle, a perfect circle actually. You wouldn't get what I just drew here. And so the next conic section we get is the ellipse. And so in order to get the ellipse, we're going to draw ourselves another two-dimensional cone here. A rather poorly drawn one at that, and basically in order to get this ellipse, we're going to take the plane and we're just going to skew it a little bit, which in turn gives us a circle that's kind of squished. Now, an ellipse can be going in any direction at any time. It can be diagonal, it can be vertical, doesn't matter. The next conic section that we get, or the next shape, is a parabola. You may recognize that from other algebra concepts. So if we draw another one of these cones, we will take our two-dimensional plane and we'll go off the side of this cone a little bit from what we're looking at. And we will get, if we draw another two-dimensional plane, one of these bad boys, which is just a curve basically. It's not a full circle. Next one we get is a hyperbola. You might also remember this from algebra concepts. Once again, we'll draw another cone, maybe one slightly better than the one that I've drawn, or all of the ones that I've drawn so far at least. And you might have guessed by now that we might be out of space on the cone. Well, you might be wrong. We take this plane and we stick it in between these two portions of this cone, and we get a shape, something like this. And so that will be two sections, which is basically just a parabola, but twice. And so that's basically all there is to know, but I'm going to go ahead and kind of push you into what some of the equations in order to find these shapes on a graph would be. And so the equation of a circle would be, if you remember this from algebra concepts, would be x minus h squared minus y minus k squared is equal to, I'm running out of space here, r squared. You can probably write that smaller, or maybe move this to the side a little bit, where h and k is equal to the center point of your circle. So h and k is equal to your center, and r is equal to your radius. Now the equations for the rest of these will have different equations depending on the horizontal axis and the vertical major axis, so whether or not it'd be going this way or this way. So for our horizontal axis, we'll say, all right, horizontal, we have x minus h squared over a squared plus y minus k squared over b squared is equal to 1. Now in order to have it for the vertical major axis, you just switch these two around. So we'll indicate that with a couple of arrows. We're saying we'll switch these around. Vertical. So for the parabola, we'll do another one we'll start on the horizontal one here. And for a parabola, the equation will be y minus k squared is equal to 4p x minus h, where p does not equal to 0. Now for the vertical axis, we will just switch the y and the x's in place. So, right, vertical. Now, for the hyperbola, it's very similar to an ellipse. So, we'll start off with the horizontal, and we will write x minus h squared. I was looking a little off the screen, sorry. Over a squared minus, so as opposed to plus, we'll put minus, y minus k squared over b squared is equal to 1. Now, the way you would switch these around is you would switch x minus h squared with this y minus k squared. So I'm just going to write vertical here. We'll do and we'll do y minus k squared over a squared minus x minus h squared over b squared. And you'll learn more about what some of these letters mean and where you can actually apply these concepts on a graph in later lessons.